on pollution of aquatic ecosystems, biological monitoring, and indicators. Our next presenter, Professor Dr. Dragojla Golub. She is Associate Professor, Department of Biology and Department of Ecology and Environment Protection, Faculty of Natural Sciences and Mathematics, University of Banja, Luka. This is in Bosnia and Herzegovina. She is expert in bioindication in freshwater ecosystems, environmental monitoring, water quality, freshwater, fish diversity, biology, and ecology. I'd like to welcome Professor. I think this summer school will enrich with your lecture. Please, I'd like to welcome Professor.
Thank you very much. Do you hear me?
Yes.
Good, excellent. Hello to everybody from Banja Luka, Bosnia and Herzegovina. I must say I have some problem with the camera. So right now I'm going to share my screen right away. Is it okay?
Yes, please.
Okay. Can you see the presentation?
Yes, we can see.
Good, thank you very much. Hello, everybody, one more time. The topic of my lecture for today is pollution of aquatic ecosystem, biological monitoring and indicators. And the subtopics or content of the lecture is mountain aquatic ecosystem, water towers of the world, types of mountain aquatic ecosystems, how mountain aquatic ecosystem can be polluted, European Union legislative, let's say it like that, for the clean water pollution control approaches, biological monitoring, who can be the indicator, response of aquatic biota to water pollution, and use of biotic indices in biomonitoring, which actually what are benefits and what are challenges. So let's start it. Probably in this part, actually in introduction, I'm going to repeat some facts that we already heard, but I'm going to be quick. However, it is absolutely known that mountain ecosystems occupies almost 25% of Earth's land surface, and according to that, around 1.2 billion of people are attracted to them. I would like to explain the term of water towers, which is widely used in many references related to aquatic mountain ecosystems. Actually, it's a symbolic term, which means water storage in function of water provision. Actually, we can say that mountains are water towers of the world because they supply half of the world's population today with fresh waters. Mountains, in that case, are very important, especially in arid and semi-arid areas, where they can contribute with 80 to 100% of the total runoff of the river basins. Of course, as water towers, they have multiple functions, as for ecosystems and water resources, but also for hydropower, sediment loads, and nutrition balance. Yeah, I must emphasize that mountains are of the global importance for numerous reasons, and some of them are supplying water for the function, let's say, of drinking water, for irrigation industry, food production, energy production, and so on. And if we analyze all mentioned above through ecosystem services, we can say that mountains provide four types actually of ecosystem services. provisioning services, regulating services, cultural and supporting services. According to provisional services, it is water with different functions, food, raw materials, energy, and so on. According to regulating services, it's a climate regulation, purification of water and air, etc. Cultural services means different kind of aesthetic and cultural values. And supporting services are connected for production of other ecosystems related on mountains. As we can see in this map and in adjective table, there is a significant difference in spacing of mountain areas in the world, of course, and also water resource contribution connected to those mountains. Mostly it is related with climatic zone and different other abiotic and biotic factors. And let's say, for example, mountains of downstream hydrology is found in humid tropic climates. Actually, just an example. We can say that mountain contribution to downstream flow varied from 32% global level to up to 95% species. Of course, genetic diversity, and according to the last mentioned, genetic were first domestic.
Professor, I think she has disconnected.
Internet problem. So should we wait?
Can you hear me?
Connected, yeah.
I'm so sorry. Somehow I lose connection. I don't know how. I really don't know. I'm going to proceed. Okay, and the last part of this slide actually is connected to the level of vulnerability of mountain ecosystem to climatic change. And here I want to emphasize that healthy mountain ecosystem regulate climate, air quality, and water flow, and have extremely important role to protection against different natural hazards. But let's move on. According to the types of mountain aquatic ecosystems, first of all, usually we think about inland or freshwater ecosystems. Those ecosystems can be natural or can be artificial. And when we are talking about artificial water bodies, usually they are slow moving or stagnant, and they are connected to some hydropower plants like reservoirs or something like that. Further, mountain aquatic ecosystems are presented with surface and underground water. And according to the presence of intensity of water flow, they can be standing like lakes and swamps, and they can be flowing like streams and rivers. It is important, of course, to emphasize that significant amount of mountain waters in form of ice or in form of glaciers. How mountain aquatic ecosystems can be polluted. This is actually my topic in narrow point of view. Maybe the better term should be degraded or with lower quality instead of pollution. But however, we can use all these terms. First of all, we can distinguish natural and anthropogenic pollution or influence. And if we are talking about the natural pollution or natural events that can lead to the lower water quality, usually we are talking about some natural hazards or occurrences like floods, strong storms, earthquakes, volcano eruptions, and so on. But most important, of course, is anthropogenic influence. And in this case, we can talk about different human activities which can lead to the water pollution or lower water quality. In that case, we can distinguish direct and indirect pollution. And indirect pollution implies arrival of pollution or negative impact on aquatic ecosystem from polluted air or polluted soil, of course. But most examples, especially on the following slide, is connected actually to the direct influence of human activities, which can lead to the decrease of quality of water ecosystems. At this point of view, I would like to emphasize the special system in mountains. Actually, it is a system water, forest, and soil, which indicates that healthy aquatic ecosystems is strongly connected to healthy vegetation, actually forest, and healthy soil, which is related to the functions of water retention, water purification, reduction of water runoff, and balanced water cycle in general. My colleague that had a lecture, actually presentation just before me, said a lot, really a lot and great about different anthropogenic activities which devastate mountain ecosystem. Of course, it is related with aquatic part of mountain ecosystem, let's say like that. But I would like to mention a few of them. First of all, it is loss of vegetation, actually the deforestation, which lead to the disruption of water cycles balance, as we of course said before. Then degradation and loss of soil by different kind of activities, direct, like some industrial activities like mining, or indirect after deforestation. Of course, we usually have the problem of soil erosion, also have negative impact on aquatic ecosystems. Hydropower plants, which usually, if the construction had dams, transform flowing into stagnant water with different kind of negative consequences. And there is also increased consumption and unsustainable exploitation of natural resources, and from region to region, it is population overgrowth. Now, I'm from Bosnia and Herzegovina, and it's an European country. So I would like to say something more about water quality protection and water quality monitoring in Europe. And according to that, special parts go to the European Union Water Framework Directive from 2000, which is one of the most important parts of European environmental legislation. The main idea of this directive, actually of this document, is that water is not a commercial product like any other, but rather a heritage which must be protected, defended, and treated as such. All the states which are members of the European Union must apply this directive into their own legislation, environmental legislation. But it is also very desirable for other countries like Bosnia and Herzegovina. Bosnia is not a part of European Union, but wants to be, let's say like that. And in other words, all the countries that have ambitions to become a part of this this community should or have adopt their own legislation according to this directive. It is necessary to develop an integrated community policy on water. Community means European Union, actually the states of European Union, and integrated approach is very important because a lot of water bodies, aquatic ecosystems, are not located only in one country, but in different countries. If there any joint activities, there is no good result in water quality improvement. Let's see. The objective of Water Framework Directive, actually the objectives are inland surface waters, transitional waters, coastal waters, and groundwaters, and they are actually a part of natural waters. But this directive also consider heavily moderated or artificial water bodies, but with different, let's say, with different approach. And according to that, program of monitoring of water quality include hydromorphological elements, chemical and physical chemical elements as a background of very important biological data, actually biological elements. Having all that in mind, we can actually estimate or determine the ecological status or ecological potential of water bodies. First term, ecological status, is connected to the natural waters. And the second term, ecological potential, is actually a status of heavily modified or artificial body of water. When we are talking about ecological status, there are 5 levels from poor to high. And ecological potential has different scale. There is no high but maximum ecological potential because we are talking about extremely influent, let's say, aquatic ecosystem. First of all, this directive requires appropriate and standardized methods. It is very important in order to compare the results from the point of time and space. According to that, step by step, let's see the following slide, which indicates that we first have to classify the water system that we want to observe and define the ecological status into ecoregions. There is approximately 25 ecoregions for rivers and lakes, according to this directive, defined on the basis of several abiotic and biotic factors. For example, Alps, Eastern Balkan, Carpathians, Caucasus, and so on and so on. The second step is to establish a type-specific reference condition. This is very, very important. And reference conditions actually present condition with no or very minor anthropogenic influence. It must be defined for each biological element separately, and it could be obtained from actual data, historical data, or by modeling. In some cases, it is pretty complicated to find those data, actually the reference conditions. And when we are talking about small streams or rivers with no anthropogenic influence at high altitude and so on, we can find the real data, actually the actual data. But when we are talking about the lowland big rivers, it could be very hard because the human impact on that kind of water bodies is very significant. And if there is no very old historical data, it is hard to estimate which is the state of unchanged communities of any kind of biological factor. Of course, that follows the next 2 steps are identification of pressure and assessment of impact. At this slide, you can see a lot of text, a lot of lines, a lot of data. Some of them are already mentioned, but I would like to emphasize several things. All of this you can see in additional learning material, of course. Those are types of monitoring, 3 types of monitoring: surveillance, operational, and investigative monitoring, which is recommended by this directive. When surveillance monitoring presents the first line of monitoring and assess long-term changes in the community. Operational monitoring is conducted in the cases when some water bodies are identified as being at big risk, and investigational monitoring is connected with, let's say, protected areas, accidental pollution, and some specific situations. And on this slide, I would like to emphasize which biological elements, actually the bioindicators, are recommended for analysis by this European Union directive. And according to Water Framework Directive, those are aquatic flora, macrozoobenths, and fishes. But notice this is for rivers. For lakes, there is also phytoplankton. I already mentioned that set of hydromorphological elements and chemical and physicochemical elements should serve as background for biological elements, which lead us to the biological elements, actually the bioindicators. So biological elements in monitoring of water quality and estimation of ecological status of water actually is the same like biological monitoring, and implies use of aquatic organisms, actually the bioindicators, for mentioned purposes. So who can be the indicator? Every organism who lives in water or in some part of his life cycle is connected to water could be the indicator. But how to choose? Different species, different taxa, different groups of organisms have different, let's say, tolerance to the changes of conditions of their habitat. In order of that, good, actually excellent indicators should react fast, should react on the minor expose of pollution or change habitat conditions, and should have specific reaction to certain pollutant. It is not so easy to find all 3 in one, but let's say those are characteristics of good, actually very, very good indicators. So it is very important to know the biology and ecology of certain organism, actually of a certain group. According to level of organization, level of biological organization, which can be used for biomonitoring, it could be different. From suborganism level, molecular, cellular, physiological, morphological, changes in behavior, and so on, according to actually ecological state of organization, like population, community, and of course, ecosystem. And at this part, I would like to say something about the use, actually the existence and use of biotic indices in biomonitoring, which are benefits and which are challenges of usage of these kind of tools. So calculation of biotic indices have special role in bioindication. It is the way to express the ecosystem status of certain water body through numerical value. And usually it is determined for specific group of organisms and very often for certain regions. So they are special biotic indices for algae, for fishes, for macrozoobenths, and so on and so on. And let's say indices for fishes, there is European indices, Croatian indices, Balkan indices, and etc., etc. So it could be connected to the group of organisms, and it could be connected to the special geographic region, which have certain characteristics connected only to that region. The calculation of biotic indexes is based on comparison between predicted and observed condition. What did that means? Actually, predicted condition is a referent condition. We talk already about the referent condition and data, the sort of obtaining data of referent condition. And all this story with use of these indices start according to one group of organisms, actually for the fishes, in 1981 by Carr, who designed index of biotic integrity and applied especially for fishes with following parameters: taxonomy, trophic position, reproductive behavior, and tolerance of certain taxa. Now, the field of my scientific work is fish, actually fishes. Why fishes? Usually they have several benefits and not so much let's say gaps or circumstances that are not very favorable, but in general those are cosmopolitan organisms. They are present in almost all surface waters. The identification is relatively easy, and their taxonomy, biology, ecology, and all similar set of data is better known than when we are talking or actually comparing with some other group of organisms. The reason for such a thing is that fishes have very clear economical value for sport fishing, for aquaculture as a food source, and so on. They have complex migration patterns, make them pretty much sensitive for interruption, even transfers and longitudinal. Well, we're talking about the river flow. Some of them can be pretty much old. Actually, the category of longevity is different, so we can talk about their reaction on environmental changes in long term of time. And I don't want to read or let's say point out all of these moments. I'm going to say that actually what are not so good moments with usage of fish as bioindicators. One of the problem is that sampling is not so easy. You need a lot of people and a lot of special equipment to catch those fishes. Then let's say I will add only just one thing, and that's adoption on change conditions in water, which can lead us to the misunderstanding of results. But of course, as we can see, usually they are very, very good group of indicators. And for the end, I'm going to say something more about the specific indices, biotic indexes, according to fishes besides IBI. And those are European Fish Index and New European Fish Index. First one is designed in 2004 and second, I think, in 2009. And they deals with the several metric parameters, which are comparing with the referent conditions. And those are habitat guilds, trophic guilds, migratory status, reproductive and life history guilds, level of tolerance on habitat disturbance, and longevity. What is guilds? Guilds or community actually is a functional group, a group of species, group of taxa with similar biological and ecological type of resource usage. And it is very useful in this kind of investigations. So one of the difference between European and New European index, yes, is that New European index actually is consists from two indices which consider salmonid and cyprinid fish species, actually species in cold water and warm water separately. And at the end, you got exact number which can indicate one of those 5 levels of ecological status according to Water Framework Directive. So this is the benefit of.
You have 1 more minute left.
Oh,
thank you very much, Professor.
I think I don't need that. Just 1 more minute. Thank you for the attention, and sorry for this interruption with connection. Thank you very much.
Thank you, Professor, for your nice, insightful presentation. We learned a lot from your presentation. You have on the pollution of aquatic ecosystem and biological monitoring and indicators. You showed 4 things as far as I understand. The ecosystem services of the mountain aquatic ecosystems, and then you tell us about the pollution sources, direct, indirect pollution, natural anthropogenic pollutions, and water, forest, and soil interactions you have described us. And then the EU directive, water quality protection quality monitoring issues you have described among us. And finally, you showed us the indicators for monitoring aquatic ecosystems, phytoplankton, aquatic flora, benthonic invertebrates, and fishes can use as indicators as far as I understand. Thank you very much for your insightful presentation, Professor.